Today's speaker is Dr. Nathan Tucher. Nathan is the Vice President of Pharmacometric Solutions at Certara. He's a leader in the pharmaceutical industry as a scientist, consultant, and teacher. He has over 20 years of experience teaching and training in the pharmaceutical industry. Nathan, welcome to today's event. I'll now turn it over to him to begin the presentation.
Hello, everyone, and I'm glad to be here with you. And we're going to be doing a choose your own adventure for this webinar. So if you go to your Mentimeter, you should have an option to choose the topic that's of most interest to you, and you can select that. And then based on the responses of everyone in today's webinar, we'll go with the most selected topic first to the least selected topic at the end. So we'll kind of order it based on what the participants want. So if you go to Mentimeter and enter the code, if you don't remember the code or you joined a little later, you can look in the chat box, and the 6-digit code for Mentimeter is located there. So I'll give a brief overview of the 4 areas where we made significant enhancements in Phoenix 8 that was recently released. So in the top left, we have enhancements to the NCA engine. So we haven't made any changes to the NCA engine since we moved from classic WinNonlin to Phoenix WinNonlin until the release of Phoenix 8. And we did 3 significant things. We added new business rules for the calculation of Lambda Z, so that allows you to specify how it is calculated. We also provided the ability to automatically flag values that are related to the Lambda Z that may or may not meet your criteria for your SOPs, such as a minimum value for the R squared or the adjusted R squared, or a maximum amount of extrapolated AUC. So that data is now automatically flagged when you run your NCA. You don't need to do additional post-processing work in a data wizard. We have added several new parameters. These are non-compartmental parameters that have been requested by regulatory agencies worldwide, and until now you had to use data wizards and other tools inside of Phoenix to calculate these parameters. They're now included directly in the NCA engine. And then finally, one of the most exciting enhancements is the ability to add user-defined parameters for non-compartmental analysis. So this includes both computed concentrations using the interpolation method, as well as defining other parameters that may not be standard. So for example, maybe you need a half Cmax value for some reason. You can actually define that, and it will automatically calculate it, include it in the output for you when you run your NCA object. Again, the objective is to minimize the post-processing work that you might need to do to generate the required output. In NLME, we made 2 major enhancements, the largest being the automatic parallelization on remote grids. If you recall, in Phoenix 7, we introduced the ability to run NLME jobs on remote grids directly from the desktop application. However, it was limited to 2 specific scenarios. We've expanded that to include all scenarios, and we've included 2 types of parallelization. And the first type is called between model parallelization. So if you have to run 10 models, it will run them all simultaneously in parallel. But we've also allowed for within model parallelization on grids. So that means if you have a single estimation run and you want to parallelize that and use 20 or 30 or 50 cores to run that one estimation model, you can do that with NLME in Phoenix 8. The really nice feature is that it's automatically done for you. So you choose the grid you want to run it on, you have the number of cores on that grid, and then Phoenix will automatically determine the optimal number of cores to run the model for you. There's no user input required. And then we've also added a distributed delay function. In Phoenix 7, we added simplified coding to allow discrete delays to occur. We've now added an additional parameter that allows to allow for a distribution of the delay time as opposed to a discrete delay time. So this is a great enhancement. We've had several posters at AUClast and Page that describe this methodology. It's a generalizable methodology that can be used to replace transit compartments for absorption models or for pharmacodynamic models, and it can even replace indirect response models. And we think that it provides more accurate evaluations of those models. In the lower left, we made a significant change and improvement into the validation suite for WinNonlin. So it is no longer a separate application. It is directly integrated into Phoenix. So if you've installed Phoenix 8, you have the validation suite installed on your computer already. You still are required to have a separate license to run the validation suite for WinNonlin. But once you have that license, you can just access the validation menu from Phoenix, and you can run your validation. We significantly reduced the runtime. So the previous versions of Validation Suite could take up to 40 to 48 hours to fully execute. In addition, they would completely tie up the computer on which the validation was being executed, because it would take over the mouse and the keyboard and everything to execute. So we've significantly reduced that to, in most cases, less than 30 minutes, and I'll even show you the example on my computer where it completed in only 7 minutes. So it's much, much faster. In addition, when you're running the validation, it will take over Phoenix, and you cannot use Phoenix concurrently when it's validating, but you can use other applications such as Microsoft Office. You can do your email and Outlook or browse the web. It doesn't tie up all the resources in the computer. And again, it's done in less than 30 minutes, so validation is much easier and more efficient. In addition, there's no delay. It's available today. It's available, actually it was available when we released about 30 days ago. And then the history of your validation is stored directly in the Phoenix application, so at any time you can go up and look and see when is the last time you validated and what were the results of that validation. And the final area that we made improvements or grouping is what we're calling the Phoenix framework. So these are features that affect any, all of the features of Phoenix. So whether you have a license for IVIVC or WinNonlin or NLME, you can take advantage of these framework features. So the first is we've added the ability to lock workflows. So you can apply a password to workflows, and you can lock them from any changes. You can still generate results inside those workflows, but you can't make any changes to the settings. This is a huge advantage for QC and QA efforts. If you have standardized analyses, you can lock them up and prevent people from changing them. You can also ensure that the same techniques were used every time without having to go back and do tedious checking of all the feature sets. We've also added the ability to load and save object settings. So this is a new take on how we set individual templates for objects in previous versions of Phoenix. We now have renamed it and called it object settings, and it's accessible directly from an object's settings window. And so you can, if you have, for example, a specific set of models or customized models in Phoenix modeling, you can save those customized models and pull them up with a single click. The same thing with plots. If you have an XY plot that you like a certain way with labels in a certain direction and certain font size, you can pull those up directly, again, with one click to select the object settings that you want. And so I can demonstrate that later. Then finally, license activation is now within Phoenix instead of the licensing wizard if you have a node, or if you have a local license. So if you're using a local license installed on your same computer that Phoenix is installed, you do not need the Farsight licensing wizard. You just go into Edit Preferences, access the licensing area, and then you can activate your license there. Again, eliminating the need to install a helper application to be able to use Phoenix. So that's the brief overview. So I'm going to throw it back over to Suzanne, and we'll look at, if you haven't voted, go to menti.com and put your vote in. I'll throw it back to Suzanne, and she will show us the results of where people are most interested.
Okay, thanks, Nathan. So again, like Nathan said, we want to know what you want Nathan to talk about. It's a choose your own webinar. So again, please, you can take your phone, your smartphone, or second monitor, and you can go to menti.com and enter 558366. Well, it looks like, Nathan, like NCA is what most people want to hear about, followed by NLME as a second favorite, followed by the Phoenix framework, followed by the validation suite. And we'll have more questions, so everyone keep an eye out for Menti for future questions. I'll give it back to you, Nathan.
Okay. Great. So we'll go through these in the order that you guys presented. If we can get to all four, we will. If we run out of time, then it looks like validation suite might get less notice. So let me review a little more in depth the new NCA features. So we have new rules for the Lambda Z best fits. So you can now specify the maximum number of points that you want to include in the curve. So Phoenix WinNonlin always starts with the rightmost point, or the last observable concentration, and then it works backwards, starting with a minimum of 3 points and then increasing as it adjusts for the maximum adjusted R squared. You can now specify that you don't want to take more than a certain number of points for all subjects. So maybe you want no more than 6 data points. You can specify that. You can also specify the earliest time for the slope, for the samples to be taken. So if you don't want any samples before 8 hours used in the slope calculation, you can specify that. And it is not applicable for the drug effect model. It's only applicable for the pharmacokinetic estimation of Lambda Z. We also had, as I said, acceptance criteria. So the acceptance criteria will not change what is calculated. It will simply flag data as being accepted or not accepted. And we have 3 different criteria that can be set. You can set them independently or you can set them together. So the adjusted R squared, you can set a criteria for acceptance for that. For example, it must be greater than 0.6, 0.7, whatever might be in your SOP or your preference. You can set the percent extrapolated of AUC using either observed or predicted. So it must be less than 20%, less than 10%. And then the last one is a new parameter that was requested to be added called span, which is the sampling interval for Lambda Z divided by the half-life. And so normally you want a sampling interval to be 2 to 3 times a half-life calculation. So a common acceptance criteria is span values greater than 2, 2.5, or 3. We can also add user-defined parameters now with computed concentrations at specific time points. So if you want to get the concentration at 8.5 hours and samples were only taken at 8 hours and 9 hours in your study, you can use interpolation to calculate those, and they're provided in your output. And then you can do arithmetic combinations of any other NCA parameters, and you can also use any carry-along variables or dose variables or tau variables in these calculations as well. So I'll show you a couple slides of how these work, and then I'll show you the software and how you can actually do it. So the Lambda Z, there's a new tab in the settings called Rules, and you can set the rules. Again, there's 2 rules, the maximum number of points and the start time not before. And in the middle of the screen, the image is showing the calculation with no rules set. And you can see that the third subject, who has the boxes around it, used 10 points in the Lambda Z calculation. And when we set the maximum number of points to 6, you can see that now they've only used 6 points in their calculation, and the value of the Lambda Z changed slightly because it used a different number of points. So you can use either the maximum number of points or start time not before, or you can use those in combination together. And here's how the start time not before works. So on the left, you have an analysis where no rule was set. And so you can see that the slope extends all the way back to the 45-minute time point. And in the example on the right, the slope stops at 120 minutes. So this might be useful if you have a modified or extended release formulation and you want to ensure that you're only calculating the terminal slope after drug has been completely absorbed or absorption has stopped. And then acceptance criteria are right below that. You can set your acceptance criteria, and again, you can set 1, 2, or 3, and it considers all of them together. When you set acceptance criteria, it actually creates a new column that's called flag, and then it has the type of flag that it is. And then in that column, it lists text of either accepted, which means you met the criteria, not accepted, so you did not meet the acceptance criteria, insufficient data, or missing. And so missing means maybe the parameter wasn't calculated. So the acceptance criteria is now missing because there's no parameter to compare it to. And so you can see in the display below how you can easily filter out the subjects or the profiles that either meet or don't meet the acceptance criteria. We also made a change to the insufficient data rules within Phoenix. So previously, the insufficient data rules were activated and reported all parameters as missing or 0 if certain criteria were met. And at times, when it reported values as missing or 0, they could have actually been calculated based on some of the data. So we've changed those and removed any imputations, and the exclude profiles with insufficient data checkbox has been removed. And now we have a new flag where we flag data with insufficient data using the n samples flag. And the n sample flag rule are shown below. Briefly, if you only have one observable concentration, and you can't insert a dose point, then there's insufficient data. However, you can still calculate a Cmax, a Tmax, a Cmin, and a Tmin because you have an observed concentration. Another example is maybe you have a non-bolus profile with one observed concentration, so it's an extravascular dose. You can actually insert a concentration at time 0 because the concentration is presumed to be 0. Now you have 2 concentrations, so it won't flag it, but it will calculate parameters, Cmax, AUClast, Tmax, and so on. And so this is a subtle change, but you can always look for the number of samples as a filter, and if you have a low number of samples, you might want to exclude those subjects from your analysis. So here are the new PK parameters that have been added to the standardized output. The column on the left is our plasma PK parameters. The column in the middle are urine parameters. And we renamed a few parameters on the right. Where it says between, it used to say DUR. And people got confused. That was intended to mean during. Some people got confused thinking it was duration. And so we just changed it to between. And so that would be between the therapeutic targets. If you have a high and a low, it'll tell you the time between it. And high was previously abbreviated without the I. And so we've just added the I to make it more understandable. And then finally, the Lambda Z intercept variable was only available in the core text output. It was not available in the tables. We've now included it in the tables. And so this is when you do a Lambda Z regression, this is the number where that regression intersects the x-axis equal to 0. Now the user-defined parameters, there's 2 cases of these. One is what we're calling computed concentrations. So it allows you as a user, you can specify the time at which you want to compute the concentration or the Y value using imputation. So the imputation method used is the same imputation method selected for the AUC calculation. So if you used a linear, it'll be linear. If it was linear up, log down, then it will use linear up and log down. In these computed concentrations, you can insert multiple times separated by commas. You can also use a sequence command, which comes from our NLME modeling. And it's shown there. It's SEQ, and then an open parenthesis, and then the starting value, and then the ending value, and then the interval. So for example, if you wanted to run a sequence where you compute the concentration every hour for 24 hours, you would write SEQ, and then an open parenthesis 0 for the start time, 24 for the end time, and then the interval would be 1 hour. And that would generate 0, 1, 2, 3, 4 through 24 hours. So these computed concentrations come out in multiple tables that I'll show you shortly. And you'll notice that it provides the time point, the computed concentration, and then actually it has a type. If you actually have an observed concentration at a time point where you want to compute a concentration, it will actually pull the observed data in. And that'll be an observed data point, and that'll be shown in the type as observed. Also, all the carry-alongs will come along with these computed concentrations. The other user-defined parameters are anything that you can dream of that has an arithmetic combination. And so you can, if you can see the middle of the slide here, it's C last, so the last observed concentration divided by the dose. And so you put the parameter name on the left of the equal sign. You actually put the arithmetic calculation on the right-hand side. A user would need to manually enter the correct units. Phoenix cannot calculate the units for you because the arithmetic combinations are infinite, and it might not get the accurate units. But you need to put your own units in, and then those units will be carried through to the tables at the end. And so the second example is a weight-adjusted clearance. And so you can use dose, you can use weight, which would be a carry-along, or you can use any other PK parameter. And you can actually have these will come as a separate table of user-defined parameters, but you can also elect to include those with the final parameters. So all the parameters will be in one output file, so it merges the two together for you if you choose. So let me switch over to my Phoenix installation, and I'll show you a few of these features. Okay, so you should be seeing my installation of Phoenix 8. And with the Lambda Z rules, I'll show you first a comparison, and then go back and show you how it was done. So you can see here, I just have a column of the R² adjusted. In the first column was with no rules, and then R² adjusted _1 was with the rules, and then the acceptance or not acceptance flag is shown on the right. And so you can see that I changed the rules, and the actual R² adjusted values are going to change for some of the subjects because we applied new rules. And the rule that I applied was that I wanted no more than 4 data points in my Lambda Z calculation. And you can see by the number of points in the Lambda Z column, it ranged from 3 to 11 points. But you can see that it's either 3 or 4 points for all of the subjects because I made a limitation. I set an acceptance criteria for the span and the %AUC extrapolated, and again, you can see the span calculations, and you can also see the AUC % extrapolated observed calculations and accepted or not accepted. So let me go back and show you how this is done. And if you look at we'll go to the NCA object where there's rules. I simply had to enter the rules down here in the settings area or the settings panel of the NCA object. And again, you can put as many rules and acceptance criteria as you want, or you can just do one, and it does them all simultaneously. So you set the max number of points to 4, and I can actually rerun this and say I want the max number of points to be 6 now. And maybe I want to remove the criteria for the span and the adjusted R². And now I can execute this NCA object again. and it'll regenerate the results. It'll actually, calculate new results with these maximum number of points in these results. And if I come back to the table, I can run it again, and I can see now that the number of points in lambda z, they range, so you have, here's the original version, and then you can see on the far right-hand side, see if I can't quite highlight a column in the table, but where my cursor is, you can see that now they're limited to, or go up to 6 hours. And so again, you have new adjusted R-squareds. So all you have to do is input this information into your Rules tab here and make those changes. So let me show how you do user-defined parameters. The new parameters come automatically. You don't need to do anything. But user-defined parameters, you come to the user-defined panel in your settings. And again, there's the option for computed concentrations, and I put 8, 16, and 23 hours are shown here. And so it's going to compute those concentrations. And then I've included parameters down here for the additional parameters. And if I wanted to add another parameter, I can just include that here. And I want to call this AUClast by dose by weight. So weight adjusted, dose normalized AUC. And as I start typing AUC, I can see that it chooses, it allows me to choose known parameters. So there's AUClast over D, and then I just want to divide that by weight. And I know that my units are the same as this one up here, divided by the milligrams of the dose. So I've just added another parameter, and again, I can add another time point, and they don't have to be in order. And so when I execute that, it's going to calculate these new parameters, and then I'll show you where they show up in the output. So in the output, we've included these user-defined output. And so this is the user-defined computed Y. And so it's like a concentration time table. And you can see all the subjects, their time and their concentration, and whether it was computed and actually their weight. And so all those concentrations are there. You also have user-defined parameters. So this is a stacked version of all the parameters. This includes the concentration parameters because you might want to use those as parameters rather than a concentration time flow. And then we have pivoted, just like you would for final parameters. So exactly the same way that you would see your final parameters and final parameters pivoted, they come up as separate tables. Now they aren't included, those parameters were not included in here because I didn't select for them to be. If I check this box and rerun, and then we look at the final parameters table, you'll see the base parameters as well as the user-defined parameters included all together in one table. Again, this makes post-processing easier because you don't have to transfer 2 files, you just have to transfer 1. So you can see over here, these last columns represent the user-defined parameters, which have now been added to the final parameters table. They're still available as independent tables, but they're just included with this checkbox. So an example of the insufficient data, and I'll just show you the results. I had an oral formulation with no samples, and so you're going to get a number of samples is 0, but then you're also going to get a flag here that says there was insufficient samples to calculate. And so this is replacing a button that used to be down here. It says exclude profiles. We're now flagging them instead of simply excluding them. So lastly, I want to show you an example with how you can use the information of flagging to present the data more easily. So essentially, this takes the PK parameters using the rules and it flagged them whether or not they met acceptance criteria. And if you can see the AUC column, the Lambda Z column, and the half-life column, some of the numbers have a star. And so there was a simple data wizard that was used, and then we output that data to a table. And in that table, you can see that 3 values were starred and not included in summary statistics because the R-squared adjusted was less than or equal to 0.98, and the percent extrapolated was greater than or equal to 20%. So they weren't included because maybe they're not reliable. Obviously, an R-squared adjusted of 0.98 is not a reasonable limit for what we normally do in analyses, but we wanted to demonstrate the capabilities. So you can easily use these flags to filter your data and then format a table like this for a report. So if you want to look back at your Mentimeter, I have a question for you is, which new feature for NCA will have the biggest effect on your work or impact on your work? So if you can go to your second screen or your mobile device and you can answer that question, I'll pass it back to Suzanne.
Okay, thanks, Nathan. So as Nathan mentioned, if you want to participate in the polling, we'd love to know what you think. You can go to www.menti.com and enter the code 558366. And we can see that there's a lot of folks responding. We'll just wait a second and let everyone input their answer. So it looks like user-defined parameters, including computed concentrations, are what people are voting for as being the feature that'll have the biggest impact on their work, followed by business rules and flags for Lambda Z calculations, and lastly, new standard plasma and urine PK parameters.
Great, thank you, Suzanne. So we're going to now move to the new features of NLME. So the first one is the automatic parallelization on remote computational grids. So it's very easy to set up. There's no user intervention required to execute a model on a grid. And all scenarios are executed in parallel across a maximum number of cores. And this supports all run modes except for the simulation run mode. So there is a bit of a time loss involved in transferring data from your local computer to your grid and then back again. And simulations generally, there's some exceptions, but generally are relatively fast. And so we think running those locally are going to be more successful. So we did not include that in this version. But let me explain how NLME is going to calculate the number of cores to use. So essentially, it's going to take the smaller number of either the number of cores or the number of subjects in your model divided by 3. So if you had a 360 core grid and you had a model with or a data set with 300 subjects, it would divide 300 subjects by 3 to get 100, and that's less than your 360 cores. So it would parallelize that estimation run across 100 cores. If you had a sort variable, so perhaps you had a sort variable of a site on a population PK analysis, and you wanted a separate set of parameters for each site, not using covariates, but actually running separate models. Maybe you had 3 sort keys with 400 subjects per sort key, and then you had 360 cores. It's again going to divide the number of unique subjects per sort key divided by 3, so it'll be 400 divided by 3. And then it's also going to divide the number of cores by the sort keys, 360 divided by 3. And it's going to take, again, the smaller number. So the smaller number would be 120, which is 360 divided by 3. And so it'll essentially parallelize all 3 runs. They'll run simultaneously, and each run will be parallelized across 120 cores. So you can see how this can significantly accelerate your modeling because it's running multiple models at the same time, and it's using multiple cores for each model. If you wanted to do a shotgun covariate search, it would actually calculate the total number of models that need to be calculated and do the same calculation. And so in this example of 6 covariate parameter relationships and 300 subjects, it would actually run all 64 models parallelized each across 5 cores, and they would all be running at the same time. And so if your model runtime was an hour, you would have results for 64 models back in an hour. So here's a table that if anybody would like this, if you want to take a screenshot, that would be great. If you request it of our support team, we can certainly send this to you. This goes through every single run mode and how it works and how an example of how it's parallelized. Basically, it's going to do any runs that can, any separate models that can be run at the same time, it will run those at the same time, such as like a covariate search forward addition. It's going to run all the models for each round together at the same time, get the results back, make a decision, and then run all the models for the next round together. And then each model would be parallelized in each of those rounds. So you can look at this and you can study this, but essentially you don't have to do any math. Phoenix is going to do it for you. So I'll show that briefly. And then we've actually simplified how you specify your computational grids. So there's now 3 options for adding remote platforms. So the first 2 were included in Phoenix 7. And these were text files either in the installation directory or in a user app directory. You can still do that. You can still update that. It's a nice way for IT departments to automate setting up grids. You can also go into the edit preferences, and there's an area under remote execution and compute grid where you can manually enter the information yourself. If information was entered in one of the text files, it'll appear here, and you can actually modify it if you need. And so this makes it much more tractable and easier to input information with a new grid. You can also import information from another user's grid or export it. So you can, for example, copy your settings for a grid to paste it in an email, and then you can select that next user can select that text out of the email and copy it and then just import it from the clipboard, and they don't have to type everything in. And as soon as you add a grid in edit preferences, it's then immediately available in Phoenix without having to restart the application. Then the last thing is we included a distributed delay function. And I know there's been a couple webinars on this and even a training session with one of our academic centers of excellence, SUNY Buffalo. And the idea is to simplify coding model delays, such as transit compartments, dual absorption models, effect compartment models, indirect response models. And essentially, we added a shape parameter to the delay function. And we also added a new delay infusion compartment to accommodate absorption delays. And we can show that it's a single line of code in PML in both cases. And what it does is I won't go through the technical details here, but it describes all the various, it describes the distribution of the delay time. So let me jump over to my NLME and I'll show you a few of those new features. So first I'll show you in edit preferences, you can go into remote execution and compute grid, and then you can set up all your grids here by entering the information that's needed. You can enter the different types of hosts, the usernames, the passwords. We allow key file names, so if you don't use username and passwords to access your grids, but private public key pairs, those can be used as well. So it's accessible right here, and you can have as many as you want that you can add or delete. And then to use it, you would simply come to your run options, and it would say execute on, and then you would choose the location that you would want to execute. So either on a grid or locally, or on one core, or locally on 4 processors, in this case on my computer. And so all you have to do is choose where you want to run it. and then you would execute the model normally, and it will send it to the grid and bring all the results back. So very easy, very simple to do. You just have to choose where you want to execute it, and you're done. The distributed delay, I'll show you really quickly the coding for that and how it's slightly different. It's not terribly different. Actually, I'm going to show you a slightly different model. I think this will be a better model to show you. I can get my text bigger in here. So this is a pharmacodynamic model, and I'll highlight this text right here. So it used transit compartments to describe a delay in production in this pharmacodynamic model. And so instead of using transit compartments, we use the delay function, and you had the production, the mean transit time, and then you have a shape parameter. So now we're going to estimate the shape parameter using distributed delay. And then there's a history value, which is KPR. So before time starts, what is the value? And it's the baseline value. Then you essentially assign this to a new parameter called delayed production, and then you can include this in any equation. And so now you have the delayed production is this long distributed delay. That's the production component, and then you have the loss component of the pharmacodynamics. And when you do the fit, you can see the fits are quite nice for these pharmacodynamic responses. So it's very easy. It's only available inside writing PML, but it's a simple way to add it in. So we're running close on time, so I'm going to switch back, or I'm actually just going to go directly into the framework enhancements right here, because I think it's easier to show you than to do it. So this is maybe an original analysis that you had, that you produced a linear plot and a logarithmic plot, and this is a bioequivalence data comparison of a reference and a treatment formulation. You can see I've added custom labels. I have put the legend in a certain location. I have colors associated with reference and treatment. And now maybe I have a second study where I have data, and now I want to do that same plot. And so I have the data in here, and what I can do is just come up to my object settings, which is right up here, and say I want to do that linear BE plot that I just did. I say yes. It's going to load all the settings. It's actually going to, if you can notice, it's going to select all the right columns. It's going to have all the settings down here, and if I go and I execute this, we will see this is new data now, but you can see the plot looks identical. So I have the same labels on the X and Y axes. I have the same colors for the formulations. The location of the legend is in the exact same place. And now it's linear. If I said, oh, wait, I really wanted this to be logarithmic, I can go up here and switch it to logarithmic. Now, I could have done that manually with a couple clicks and options, but perhaps there were other features that I wanted to change. You quickly change it, and you now have it there. This also works on other objects as well. So, for example, here is my NCA object, and I wanted to do a specific type of NCA analysis with settings. I can load those settings in. Now it works on NCA. It's got all my carries located, and I can actually now execute that NCA object, and I'll be assured that I'm using the exact same settings as the ones I saved. So it's very, very easy to load up settings for any of these objects inside of Phoenix, and it applies to nearly every object. There's a couple like the reporter that it doesn't apply to. And you can see there are the results, but all the settings were exactly the same if I had any settings. It's going to do everything exactly the same way. So the other piece that is useful is locking work. Oh, actually, let me go back. I forgot to show you how you save a setting. So if you want to save a setting, you have a graph the way you want it. You can simply click this little save button up here by object settings, and you can save it, and then you can write a name. You can also replace a setting. If there was an existing setting, I think this was the linear graph, and I just want to replace it, I can save it as the same name, and it's going to now update the settings. So I'll go ahead and update the settings. If I want to save it as a new setting, I can just type in the new setting name, and then it will save it, and then the new setting is now available to me to use. You can also import object settings that can be mailed, and you can, if you go into the preferences, there's also object settings, and you can see all of the object settings for XY plots, and you can actually export these to email them to other users, and you can also import them and save them here. You can also delete them and save them as defaults. I think get to two more things really quickly, and then we'll have time for questions. You'll notice that we have the lock icon here. The lock used to mean that an object was running in Phoenix and you couldn't make a change. We now mean that it actually is locked, so you can't edit anything in there. So if you look, it may be hard to see on the screencast, but it's grayed out instead of black text. And if I go into any of these objects, I don't have any options to set. I can't change any of the mappings. I can't change any object settings. There's results there that when it's run, the results will exist, but I can't do anything. So you can actually run a locked workflow, and you can execute it, and it will go through and execute everything, but you can't make any changes to that workflow. You can also take the output of a locked workflow, and you can send it to a new workflow. So if I wanted to take output from any of these and send it to a report, or I wanted to export it, I could. So if I wanted to, for example, look at this bioequivalence table, and I wanted to export this, I could go ahead and I could export that. So you can, but I can't change anything about the settings in this. It's all locked up. So this is really useful. Now it's important that you'll notice I can't change any settings on input data, and so the input data needs to be outside of the locked workflow, and you can see here I used a data link to do that. And data links are really easy. Once you create your locked workflow, you just need to right-click on the white space, and there's this option here, Connect External Sources to Data Links. And that will create the data links for you. It creates the data links outside, and then everything's locked inside. Now, how do you lock and unlock? You can right-click on the object, and you can unlock the workflow and just type in the password, and it will unlock it. And now I can go in and I can edit items inside the workflows. Now I can make changes if I want. And if I want to lock the workflow, I would go back and right-click, and now I would lock the workflow. And the name is just anything that you want to put in. It's helpful to have the name to know who locked it. It's important. Passwords cannot be recovered. Certara has no way of extracting your password. If you forget your password, it will be locked permanently, and there's no way to unlock it. We did this for security reasons, but also to assure that QA groups will know that once it's locked, it was locked. Now, locking and unlocking activities are actually stored in the history of the object, too. So if you look in the history of the object, you can see when it was created, and you can see the locking and unlocking that happens. So you can actually check that. So if you're using this in PKS, that would, that would have a Part 11 compliance, because you have the history here and then the Part 11 compliance with the file. So the locking and unlocking is very simple. The key to using it is you want to make sure that you have your data inputs outside the workflow, and then you can actually take this workflow here, and I can make a copy of it, and then I can paste it, and now I have a new workflow here that has that locked workflow in it, and I can connect new data to my input data set, and then I can be off and running. So if I compare to my data, and I put data set 2 in, and now I can run this workflow, and it'll generate new results for me with this locked workflow. Excellent. So I think we'll go to another, we'll actually go to one more question and ask, what are your biggest analysis process and QC check challenges? And so this is a word cloud. So if you could just type in, it's free text, what are the biggest challenges that you have with your analysis process or your QC checks that you'd like assistance with, and as those words come up, the more common words will show up more frequently. So you see it changing as people are inputting their words in.
So this is great. Thanks everyone for their responses. We see some folks are struggling to get things into CDISC format, or their audit trail. That appears to be a really popular one. Statistics, reporting, dealing with outlier data. Definitely good to know. Thanks everyone for giving us that feedback. Now I'm going to hand it back to you, Nathan. So
I think we'll go to questions, Suzanne. There's only about 6 minutes left, so why don't we go to the questions and answer a few of the questions that have been submitted.
Okay, perfect. Everyone please put in your questions in the Q&A box for Nathan. Nathan, first question from our audience. Someone would like to know, can you copy a locked workflow to an unlocked workflow?
So you cannot unlock a workflow by copying it and pasting it. So that cannot be done. Well, you can't actually even copy a locked workflow in and of itself. If you'll notice in my demo, I had a parent workflow that had a locked workflow inside of it. I can copy a parent workflow which is unlocked and paste it anew, and it will create the locked workflow underneath it. So you can do that, and you can put them anywhere you want. You can have nested locked workflows, and those nested locked workflows can have different passwords. But there is no way, once a workflow is locked, you can't copy it, you can't paste it by itself, and there's no way to unlock it without the password. So I hope that answers your question.
Nathan, someone from our audience would like to know about overall settings. Is it possible in Phoenix 8 to set a standard font that can be used throughout a project?
So if you set up, when you have the object settings, you can set so there is a standard font that is set up in Phoenix 8. You can change each object setting to have a different default object type, and that default object can have the font that you choose. So that can be done. There is not an overall setting at a project level where you set the font for a project and then every item, every figure or plot or table has that same font within a project.
Someone would like to know, is it possible to calculate the time when the concentration reached a certain level? I.e., if you know the concentration level, can you calculate the time at which you reached it?
Possibly. I'd have to think about that one a little more to understand exactly how to do it. You might be able to do it with the therapeutic windows in the NCA object, but I probably need the support team to dig into that a little. So I'd encourage you to ask that question on our forums, and I know that our support team would be happy to answer it, especially if you had a simple example data set to put up there. It's probably something I can't answer in a minute on a webinar. Suzanne, if those were the key questions and I have 2 minutes left, I could jump over and show the validation suite for WinNonlin.
Sure.
At least how the report comes out, and then we could close. Does that sound good?
Yep.
Should have to hand the ball back to me so I can share my screen.
Yep, there you go.
So I thought we might run out of time, but I thought I'd show it really quickly with validation. If you have a validation suite license, this should now be active. The template documents are available. It'll open up a file browser, and you can see all the files that are included. In your validation reports, you can see all of your historical validation reports. So the last one I ran was on October 26th, and as soon as you click it, it'll open up the Word document, and it has a document ready to be signed and submitted as part of your validation package. And it includes all the information about the test, as well as the detailed results of the tests that were passed. If you'll notice here, the total runtime was just 7 minutes. So it's very, very short runtime. And the average time per test was about 2.5 seconds. So we've significantly reduced the total runtime for this. And I think the last thing that I'll show you in the 30 seconds I have left is how you would start a validation. You put a username in there, you select WinNonlin, and then you just check Start Validation. And then what it's actually going to do is it'll spin for a bit as it gets itself set up, and then a window will pop up and it'll show all the validation tests that are prescribed, and then it starts walking through those tests and testing them. So if you can see, there's a blue circle, means it's actually running the Phoenix installation test right now, and then all of these ones have not been run yet, and it'll actually show you what is being compared. And so you can actually see the comparisons running. The green ones are the tests have passed, they've been completed, and they're ongoing. And you can see Phoenix flashing in the back because it's running Phoenix to do all these calculations, but I'm free to work on other applications on my computer. So it runs pretty quickly, and you can see it's pushing through those. It's got 8 done already in just a few seconds. So I think I will stop sharing here while this is running, and I'll turn it back over to Suzanne for a few final comments.
Okay, thanks, Nathan. And I'd like to thank everyone for attending today's webinar and